So in this video, we are going to talk about where the electrons are located in the atom. To this point, we know that the electrons are located somewhere outside of the nucleus, and it's usually described as an electron cloud. It is going to be incredibly important for you to know and understand where and how those electrons are located outside of the nucleus of the atom, because how those electrons are arranged has an enormous impact on the properties of those particular atoms, of those elements. And it's going to determine what sort of bonding those atoms, those elements undergo, and what sort of reactions those elements undergo. Okay, so when talking about where the electrons are located around that nucleus, we are first going to talk about energy levels or energy shells. And I tend to use energy levels more often than I do energy shells. Your instructor may focus or call them shells as opposed to levels, but they both mean exactly the same thing. So the first model that we had of exactly where these electrons are located is called the Bohr model of the atom. And don't worry about the name of that particular model, but it's sort of a planetary model for where those electrons are located. And so here, let's try a different color. Here is my nucleus. I've got a positive nucleus. And we have found that there are 7 shells, 3, 4, and you get the idea, right? I could go out to 7, but that each of these rings is a shell or an energy level, and there are 7 total. That lines up beautifully with the number of periods on the periodic table. Right, there are a total of 7 periods on that periodic table. And what we're going to find is those are going to correlate directly with the number of rings or number of shells around the nucleus of the atom. Now what's interesting is what we found is that Bohr model did not hold up for atoms that had lots and lots of electrons. It worked really nicely for hydrogen, but nothing larger than that. And so that leads us to the quantum mechanical model of the atom, or the quantum model. And what this model says is that inside of each energy level, we have sublevels or subshells. And there are 4 different types of subshells. There's an S subshell, which literally is a sphere. So think about it like a baseball or tennis ball. And that S can hold up to 2 electrons. We have P subshells or sublevels. These are sort of like a figure 8 shape or a dumbbell type of shape. A lot of times I have my students think about this like a peanut type shape. And those can hold up to 6 electrons. The d orbitals or d sub levels can hold up to 10 electrons, and the shape of these start to get very strange. And then the F shells or subshells can hold up to 14 electrons. Okay, so now what we're going to do is we're going to take that information that we learned on the previous slide, the fact that there are 7 energy levels, and there are S, P, D, and F subshells. And we're going to place this information on the periodic table. I highly recommend that you have a copy of your periodic table so that you can go ahead and write directly on this. I would also have colored pencils or markers or something so that you can label this as needed. All right, so the first thing I mentioned in the previous slide was the fact that we have 7 energy levels or 7 shells, and we have 7 periods. Now, that has been labeled for you on the left-hand side of your periodic table, right? Hydrogen's in period 1, lithium's in period 2, sodium's in period 3, all the way down to francium in period 7. I would go ahead and write these numbers on the other side as well. Just kind of helps to keep everything straight, right? So Helium is in period 1. Oh, that's terrible. 1. Try that again. 1, 2, 3, 4, 5, 6, and 7. Okay. So now that we have the periods labeled, we're going to go through and show you where the S block is, the P block, D block, and F block. And what this is going to correlate to is what subshell is actively being filled in that for that particular element. All right, so my S block elements are going to be in the first 2 columns. So they are going to be right here. Right here. And notice I left a space next to hydrogen. So helium, even though it sits over here on the right-hand side of the periodic table, and it sits there because it does behave, it is a noble gas, and so it does behave, has very similar properties to the rest of the noble gases. When we're talking about its electronic structure, it actually is going to be in the S block. Okay. Now, so let's go ahead and label that. So red means that those are my S subshells, my S block. There are 2 blocks, right? And if I look at hydrogen and helium, that adds up to 2 spaces, 2 blocks. That corresponds to the number of electrons that that S subshell can hold. So 2 blocks equals 2 electrons. Okay. Talk about the P's next. So the P subshells, and the P subshells are located all the way over on the other side of the periodic table. Okay, so those are my P's. And remember that we said that the P's can hold 6 electrons. Well, if I count the number of blocks going across in that period, there are 6. That correlates to 6 electrons for the P's. And again, note that helium is truly in the S's, and I did not include helium in the P's. The next are going to be the D's, and this is where the transition metals are. So right in here, I really wish I could draw a little bit better. These are the D's. And if I go ahead and count across, I will have 10 blocks, 10 electrons. Now the last pieces, and we don't really deal with these very often, really if at all in this course, and that's these guys down here. These are referred to as the inner transition elements. These are your F block, and if I count up the number of spaces going across, there are 14 electrons. Okay, so this basically shows you exactly what we just did and what we just talked about in the previous slide, and having you write on your periodic table and put where the S blocks are, the P block, the D block, and the F block. Now, the one thing about this slide that this highlights is this number out in front of the block, right? So again, remember that helium over here really goes here. But you notice that going across that first row, that we're talking about the S block, and that is labeled with a 1 outside of the front of it. And if I go down to the second period, that is labeled with a 2. And it's labeled with a 2 for the S's, and it's also labeled with a 2 for the P's. That number out front lets us know what energy level we are in. So that number right here, that tells us about the energy level. And it lets us know which energy level we are in. It's followed by the subshell, so it tells you what energy level and subshell that particular of those electrons are in. One thing that I want to point out that is just a little bit odd, if we go down to period 4, so you'll notice that here we deal with 4s, and then we go to 3D, and then we go to 4P. I'm going to talk in a couple of slides from now exactly why that is, but for the moment I want you to think about the D block elements, and it's going to be the case going right for period 5. We go 5S, and then we go 4D. I want you to be thinking about the D block elements actually are going to be in a lower energy level or a previous energy level. So as we're filling up, we would fill up 3S, 3P, then 4S, and 3D. And same thing, 5S, then it goes to 4D, and then 5P. And again, we really are not going to deal much with the F block elements. Those guys are down here, and they really go right here, right? They were actually moved and put down on the bottom to make the elements fit on a regular piece of paper. But if I'm going across, right, in period, so 4F is really in period 6, and 5F is really in period 7. And as I'm going across, right, S is 6. F is actually, for going across period 6, F is actually 4. So for the F block, they are 2 below, or 2 previous energy levels but before the period that you're actually in, if that makes sense. But again, we're not really going to deal much with those F block elements. And I promise, as we start to practice with these, I promise I will do some D block elements so that you can see exactly how to go about filling that up. Okay, so here's a bit of information that I wanted to make sure that you had and that you understood. So basically, I'm taking this information from the previous slide, I'm just consolidating it right here. Very important for you to know that in energy level number 1, right, so period number 1 only has an S block, only has S subshells. For energy level number 2, or period 2, and again, think about the number that goes in front of the subshell. For energy level number 2, I only have S's and P's. I have an S block, or I have S subshells and P subshells. Remember that the S subshell holds 2 electrons, the P subshell holds 6. So for that full energy level, I have a total of 8 electrons. For energy level 3, I have S, P, and D. S are 2 electrons. P are 6 electrons, D are 10 electrons. So that gives us a total of 18 electrons. And then for energy levels 4 and up, we have S, P, D, and F. S is 2, P is 6, D is 10, F is 14. Add those all together, and that gives you a total of 32 electrons. Okay, so now that we have some of the background information, we can go ahead and start working on our electron configuration. So there are 2 things I want you to be thinking about when doing this electron configuration. Number 1, this is essentially assigning an address to the electrons. We're telling everybody where, what energy level, and what subshell those electrons are existing in. The other thing I want you to be thinking about is we're going to move across the periodic table sort of like it's a board game. And I'll explain that as we do some examples. So the first one we're going to take a look at is we are going to take a look at hydrogen. Now hydrogen sits right here. Hydrogen has 1 electron. So we need to tell everybody where that electron exists. Well, that electron sits in the first energy level, right? So it sits in energy level 1. That electron, we've moved 1 space into the S block. So I have that electron sitting in the S block, and then I'm going to, as a superscript, that's a terrible one. Let's try that again. I'm going to have a 1 superscript here, and that just tells everyone that there's 1 electron in that S energy, or that S subshell in energy level number 1. So we have the energy level, we have the subshell, and then we have the number of electrons in that subshell. Okay, so far we've taken a look at the electron configuration for hydrogen. And again, we're talking about where those electrons exist around the nucleus of the atom. And again, you want to think about these as sort of like an address for each of the electrons that exist in the atom. So we're going to do a few more examples, and we'll do some that are a little bit more complicated than hydrogen. And so the first one we're going to take a look at is helium. And like I said in the previous slide, I want you to look at the periodic table as though you're moving across a board game, sort of like a Candyland or something like that, just no chutes and ladders. And keep in mind the blocks, right? Where the S block is, where the P block is, the D block, and the F block. And again, keeping in mind what period you're actually in. So before we get started on this, I am going to go ahead and just draw my periods, or write out my periods on here. And remember, it would be awesome if I could count, right? Remember, these correlate to the energy level. And also keep in mind our blocks. These first two are our S block. Remember that helium really should go here. Our P blocks, our P block is right in here. And our D block is right in here. And then our F block is down here. Okay. So for helium, I'm going to go ahead and go across, right? And I'm going all the way across that first energy level. Helium is in an S block. It's got 2 electrons, right? So we know that helium has 2 electrons. And so both of those electrons are going to exist in that first energy level in the S subshell, and there are 2 electrons there. So my configuration for helium is 1s2. Okay, I'm going to take a look at lithium next. Now lithium is element number 3, so it sits right here. We know that lithium has 3 electrons, and when I go to figure out my configuration, again, I'm going to use this like I would a game board, and you always start from the beginning, right? So I'm always going to start in energy level number 1. That has to get completely filled up first. So I am going to go completely across energy level number 1. And so filling that up gives me 1s2. Keeping in mind, and I would definitely write this, that energy level now is completely full. Once I've put 2 electrons into that first energy level, it is full. And now I am 1 space into the S block in period 2. And so that means my configuration here is 2s1. So my complete configuration for lithium is 1s2, 2s1. The last one I want to take a look at is oxygen. Let's get rid of these arrows here so we don't have too much of a mess. Okay, so oxygen is right here, and oxygen is element number 8. So I know that I have 8 electrons in oxygen. And one thing I forgot to mention, you can double check yourself to make sure the configuration is correct by adding up how many electrons you have. So for lithium, I had 2 electrons in 1s, 1 electron in 2s, and if I add those together, that gives me 3 electrons, which matches exactly how many electrons are in lithium. Okay. So we're looking at oxygen and looking to fill or figure out the electron configuration for oxygen. So like I mentioned before, always start at the beginning. So I'm going to go completely across and fill up 1s. And so I've gone through to the 2 s blocks, so 1s2. Now I'm in period 2, and I'm going to go straight across the s block. So I've completely filled up the s block, that is 2s2. And now I am 4 spaces into the p block, still in energy level 2. And so that gives me 2p4. So my complete configuration for oxygen is 1s2, 2s2, 2p4. And again, if I wanted to just double check and make sure that I have the correct number of electrons, I have 2 plus 2 plus 4. If I add all of those together, that gives me 8 electrons. Also want to point out that 1s is completely full. That first energy level is completely full. This will become important in a little bit. Okay, so we've just gone through the electron configuration for several elements, including hydrogen, helium, lithium, and oxygen. And so what I want to do is I want to step you through what these look like based on 2 models. So the first is the orbital model. So as you can see in the orbital model for hydrogen, which has a configuration of 1s1, that 1 electron is in that first energy level, and in the orbital model it shows it rotating around the nucleus of the atom. The quantum model actually gives us a slightly better picture of where we think that electron is. So the s orbital here, or the s subshell, is shown in blue, and it's 3-dimensional. Think about it like a sphere, and somewhere in that sphere exists an electron. And that's about, excuse me, that's about as close as that electron can get to the nucleus. Now, helium has a configuration of 1s2. So those 2 electrons are in that first energy level in that s subshell. And so you can see the quantum model doesn't really look much different, but the orbital model does show those 2 electrons in the s, in that first energy level. Lithium, a little more complicated. The configuration for lithium is 1s2, 2s1. So the 2 electrons in the first energy level in the s subshell, you can see in the orbital model, are very close to the nucleus, and that 3rd electron that's in the second energy level is significantly farther away. The s subshell in the second energy level is shown in pink. And so if this were to be a little bit more open, I'm not sure why you can't see the blue center, but the blue center is still there. So that subshell in the first energy level, the s subshell, is still there with 2 electrons in it. And then farther out from that is that s subshell. Okay, so this is, we are going to see next, oh, there we go. There is that subshell, the first subshell. Now, oxygen. Oxygen is 1s2, 2s2, 2p4. And so in the orbital model, what you see is you see the 2 electrons in the first energy level, and then in the second energy level, so that would be 2s and 2p, you have a total of 6 electrons. And so those 6 electrons are, in the orbital model, shown as orbiting around the nucleus of the atom. If we take a look at the quantum model, you can still see that center, right? You can still see that 1s subshell right there close to the nucleus. You can still see farther out from that pink sphere. That is the second subshell, or the s subshell in the second energy level. That has 2 electrons in it. And then we have the p's. The P's, as we mentioned, are a dumbbell shape, or I like to think about them like a peanut shape, right? They kind of do sort of a figure 8. And there are 4 electrons in the P's. And you can see the P's shown here. It's like a reddish, orangish color. And that's where those 4 electrons in the P's are located in those dumbbell or peanut-shaped regions. Again, you want to think about that second energy level as being a specific distance away from the nucleus. This is going to help, and hopefully these visuals help you when we start to talk about trends and atomic size and ionization energy in a couple of slides or a couple of videos.